In today's video, we're going to be looking at section 7.1, which is visual representations of data. So we're looking at different types of ways that we can represent a data set in order to see it more visually and see exactly what is happening as a picture. Okay, so bar charts you've seen before, you've probably seen pie charts before. We're also going to look at histograms and box plots. First thing is the bar chart. So we have here a list of different highest degrees that are planned amongst a group of 141,189 students. Okay, so we've got a ton of students here, and it tells us what the highest degree that they are planning on taking actually is. So we've got the number of each one, so the number that say that the bachelor's is the highest degree that they're going to take, the number that say that the master's is the highest degree that they're going to take, etc. And then as a whole, what they've said is, okay, this is the percentage of the whole that plans on doing each of these degrees. So 21.1% of the 141,189 people plan on taking a bachelor's degree as their highest degree. 42.1% plan on taking a master's as the highest degree. So it's 42.1% of the 141,189. Okay, so it's given each of these numbers as a percentage of the whole. First thing is we're going to look at different ways of representing this using a bar chart. So we've looked at, here is each of the degrees that people plan to take, and this is the number of people that plan to take each of those degrees. So you'll see on the x-axis here we have each of the degrees, and on the y-axis we have the number of people that plan to take that, and then you just draw a bar for each one. So the bachelor's degree, we go up to 29,791, which is just below that 30,000 mark. And I know that this is very difficult, especially with a graph like this. It's very difficult to kind of see what's going on, because I know that each tiny notch is 10,000. So trying to plot it to 29,791 is kind of difficult. But that is what they have done here, and that's the scale that they have chosen. There will be different scales depending on the problem. Okay. Similarly, what they've done in this second bar chart is to list each of the degrees, but then list the percentage of the whole that plan on taking that as the highest degree. This one would probably look a bit more accurate. Okay, it's a bit easier to read exactly what's going on, as we have a much lower scale here. So we've only gone up to 50% on our scale, and it's a lot easier to read off some of those marks, or at least get to a rough idea of what the percentage of each one is. So we said that 21.1% of people plan on taking a bachelor's, which is just above that 20% notch on that y-axis. Okay. So there's different ways that we can represent this data set using a bar chart. And again, depending on the problem, depends on how you may want to do this. Another popular type of visual representation of data is a pie chart. So instead of this time using these bars to represent our data, we are taking one complete circle, and then each part of the circle is going to represent, in this case, the highest degree that is planned. So we can see here that this blue area that we've sketched out here is the bachelor's degree. It's the percentage of people that plan to take a bachelor's degree. So if we say that this entire circle represents 100%, then we've taken 21.1% of that whole circle to represent the people that plan on taking a bachelor's degree. And then we've taken 42.1% of our circle to represent the number of people that plan on taking a master's degree. How do you figure out exactly how to do a pie chart? Well, what you need to do is to look at the percentages, so exactly what we have here. And what I want you to do is to multiply each one of these by 360. Okay, there's 360 degrees around the circle. So to figure out exactly what the angle would be in the circle for a particular section, that's exactly what you need to do. You need to multiply the percentage by 360, and that will give you what the angle is in degrees that will represent that particular section. So here, if I've got 21.1, I'm going to multiply that by 360 degrees, and you should get, rounded to one decimal place, 76.0. Okay, so you should find here that this angle in my sector for my bachelor's degrees should be 76.0 degrees. Okay, so then you can use a protractor and you can go ahead and mark that out. We tend to always measure from the vertical line here. Okay, so you start with a vertical line that goes from the middle of the circle up to the outside. Start with that vertical line at the top, and then we're going to measure around for each sector. And you should find when you multiply each of these by 360, so if you multiply 42.1 by 360 to one decimal place, it's going to be 151.6 degrees. So this angle here is 151.6 degrees. When you go through all of this, you should end up with 360 degrees as a total. Okay. So just do that for each one. I'm not going to do them all here, but you can get the idea. This part here is 68.4 degrees, and you can plot out the whole circle. So that's how we would draw a pie chart. You are going to get this number of people that are in each particular group. You're going to figure out the percentage of people that are in that particular group as a percentage of the whole, and then you're going to multiply each of those percentages by 360, and that will give you the angle in the pie chart for each section. Next we have histograms. Histograms are very much like a bar chart, but now we're trying to represent numerical data instead of any type of qualitative data, anything with words in it. So you'll see here from our bar chart, each group was represented by a word. So you had the people that were taking a bachelor's as the highest degree, the people that were taking a master's as the highest degree. Now with histograms, everything is in numerical data. Okay. You will be given a list of numbers. So in this case, we're looking at quiz scores. Okay, there's 25 students and they've all taken a quiz, and this is their quiz score. Okay. First thing you need to do whenever you get this long list of data is you need to somehow condense it into a table and figure out how many of each number that you have. So we look at the number of zeros, ones, twos, threes, fours, etc. So that's what we have in this table here. We've figured out how many people got a 0, how many people got a 1, how many people got a 2, etc. Once you have organised your data, you can go ahead and draw the histogram. Now the way that we draw a histogram is that around each of the numbers we draw a bar. So it goes halfway between the last number and the next number. So you'll see here 0, the bar that represents 0, we put that bar in the middle of the notch that represents 0. Okay, same with 1. We draw the bar around the notch that measures 1, etc. And you go up as high as the number of people in that particular group. So the number of people that got a 0, the number of people that got a 1. Okay. So that's the only difference between a histogram and a bar chart. Number one, you are representing numerical data. So each group is represented by a number. In this case, we're looking at a particular quiz score is each group. Okay, and then you go up on the y-axis however many people are in that particular group, exactly like a bar chart. And we draw each of these bars centered on each of these notches. Okay. The last type of visual representation of data that we look at in this course is a box plot. I'm only ever going to give you simple box plots to look at because there is a bit more to this. It is possible to do these on the graphing calculator. They can just be kind of difficult to read. If you do them on Excel, they are a lot easier to read, but on a graphing calculator, it's kind of difficult to see where the numbers fall. So if you are in a pinch and need a rough idea of what this box plot would look like, you can go ahead and do it on the calculator, but I wouldn't recommend it, especially for like exams and stuff. It's difficult to read them. If you do need a second way of doing a box plot, I would recommend Excel, but like I said, I'm not going to give you anything that's super difficult to figure out. What is a box plot? Well, it's a way of representing the spread of a data set. Okay. I'm going to look at another class who has taken a particular quiz, and we're going to look at the scores that they got. So the numbers that I'm going to use are 1, 3, 6, 10, 15, 21, 28, 36, 45, and 55. Whenever you deal with box plots, the first thing I want you to do is make sure that your data set is in order. Okay, these numbers are all in order. I've done that on purpose. Okay, but the first thing you need to do is make sure the numbers are in order from lowest to highest. Otherwise, this will not work. The next thing I want you to do is to figure out the median of the set. Okay. Now, you've probably heard of the median before. Okay. The median is pretty much the middle number of a data set. So it's another way of finding an average for a data set. We will look at the mean for a data set later on in this chapter. But right now we're looking at the median. The median is the middle number in the set, such that half of your data is lower than that number and half of your data is higher than that number. Okay. If we look here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 data points. Okay. The problem is, in order to find the middle number, when you have an even number of data points, your middle number would fall somewhere between those two central data points. So here, our median is going to be between 15 and 21. If I had 11 data points, so let's say someone got a 0, so I had 11 data points. If that was the case, then to find the median, I would just count out where my middle value would be. So I would have my two outside values, and I would work my way inwards, leaving me with 15 as my middle value. Okay, so if you have an odd number of data points, you just take the middle value, okay, which in this case would be 15. However, for our example here, we actually started out with an even number of data points. So an odd number of data points, it's easy, you just pick out that middle value, that is the median. When you have an even number of data points, what I want you to do is to take the two central values and find their average. So in this case, to find the average of the two center data points, I'm going to do 15 plus 21 divided by 2. You're finding the average of the two middle data points. So if you do that, you end up with 18. So my median here is 18. So like I said, if you've got an odd number of data points, pick the middle value in your data set. If you've got an even number of data points, pick the two center values and find their average. The next thing that you need to do is you need to find the upper and lower quartiles. What does that mean? The lower quartile is the median of your lower 50% of data. Your upper quartile is the median of your higher 50% of data. Okay, so in this case, the lower quartile, the median of my lower 50% of data is going to be, I've got 5 data points in my lower set, which means that I can just pick out my middle value as the median of that lower 50% of data, which is 6. Okay, same with my upper 50% of data, okay, the higher 50% of data. So on the other side of my median, I have these 5 data points. To find their median, I'm going to pick out the middle number because there's 5, an odd number of data points. So that tells me that my lower quartile is 6 and my upper quartile is 36. So your lower quartile is always the median of the lower 50% of data. So it's the median of the numbers that fall below the median of the data set. And the upper quartile is going to be the median of the values that fall above the median of the data set. Okay, so the lower quartile is the median of the lower 50% of data. The upper quartile is the median of the higher 50% of data. Okay, if you have an even number of data points either side of the median, then you are going to have to take the average of the center too, exactly like we did to find the median of this whole data set. Okay. The last thing you need in order to draw a box plot is the upper and lower values. So the minimum value in this data set is 1 and the maximum value is 55. Okay, the highest and lowest points. Now we can go ahead and draw a box plot. What you need to do, go ahead and draw yourself a number line, an x-axis. Okay. I'm going to start this at 0, and I know that my highest value is 55, so I'll go up to 60, and I'll draw out some notches here. This won't be accurate, but we're only looking for a quick sketch here. Okay, so I've got 10, 20, 30, 40, 50, and 60. Okay. What you need to do is you need to draw lines where the minimum value is, the maximum value is, where the upper and lower quartiles are, and where the median is. So my minimum value was 1 and my maximum value was 55. So I'm going to draw a line at 1 and I'm going to draw a line at 55. Okay. Next are my upper and lower quartiles. So my lower quartile is 6, my upper quartile is 36. I'm going to draw a line at each of those values. And then finally, my median was 18, which would be around there. Okay. Once you've drawn these lines, what I want you to do is to draw a box where we have the lower, upper quartiles and the median. Okay, so you're going to draw a box that starts at the lower quartile, ends at the upper quartile, includes the median. And then you're just going to draw a line that connects that box to each of the maximum and minimum values. This is a box plot. It shows us the spread of the data. Okay, this tells me that a lot of the data actually lands in the lower end of my scale between 1 and 55. Okay, my box where the majority of my data is, the majority of your data is going to be around where that box is. Okay, so I can see that that box is to the left, telling me that a lot of my data lands to the left on my number line. So that tells me that a lot of my data is lower values rather than higher values. Okay, so that box contains the middle 50% of data, which we can see here falls to the left. So my middle 50% of my data is actually lower rather than higher. Okay, my middle 50% of data is actually smaller values rather than higher values because it falls lower down my number line. Okay, the wider the box, the bigger your spread of data. Okay, same with the longer the lines, the bigger the spread of data. So that is why we like a box plot. It can show us the spread of the data, where the majority of our data lands, where our maximums and minimums are. Okay, so just to recap this again, to find a box plot to show the spread of the data, first make sure that your numbers are in order going from smallest to largest. Next, you're going to find the median. If you've got an odd number of values, just pick out the middle data point. If you've got an even number of values, you take the average of the middle two. Then you need to find the upper and lower quartiles for your data. The lower quartile is the median of your lower 50% of data that lands below the median, and your upper quartile is the median of your higher 50% of data that lands above the median. Find your maximum and minimum values. Then you can go ahead and draw a box. You draw lines where you've got your maximum and minimum values, and you draw lines where you have your lower quartile, median, and upper quartile. You draw a box between the lower quartile and the upper quartile, which includes your median, and then you just draw lines out to your minimum and maximum. And like I said, if your box which contains the middle 50% of data, okay, if that lands lower on your number line, then you know that the majority of your values are lower. If it lands to the right on your number line, you know that the majority of your values are higher. And also, the longer the box, the larger your spread of data. Okay. One last thing I also want to point out. The quartiles, the reason that they are called quartiles is because they split your data into roughly 4 segments. Okay. Roughly 25% of your data is less than the lower quartile. Roughly 50% of your data is less than the median. So you should have about 25% of your data between this lower quartile here and the median. And then roughly 75% of your data should be less than the upper quartile. So there should be 25% of your data between this median and the upper quartile. So there should be 25% of your data roughly here, 25% of your data here, 25% of your data here, and 25% of your data here. So the reason that they are called quartiles is because they should split your data into roughly 4 segments, with 25% being lower than the lower quartile, 75% being lower than the upper quartile, 50% being lower than the median. Okay, so they split these into 25% segments. Okay. One other value that you may be asked is the interquartile range. It is the difference between your lower and upper quartiles. So the interquartile range is going to be the upper quartile minus the lower quartile, which in, I guess, algebraic terms, to like notation wise, we actually say that the upper quartile is called Q3, the lower quartile is called Q1. And just to kind of keep in line with that, sometimes they call the median Q2. Okay, so you have Q1, Q2, and Q3. If you ever see those as notation in homeworks, etc., that's what it means. So the upper quartile we call Q3, the lower quartile we'll call Q1. So back to our example, our upper quartile was 36, our lower quartile was 6, so our interquartile range was 30.